Hi everyone. Hi everyone. This is Kumar Swami, lecturer in electrical department in GPT area. Today topic is windings. Content of windings. What is armature winding? Terms related to armature winding. Single layer and double layer uh, windings. Comparison between closed and open winding. Types of DC armature winding. Types of AC armature winding. So first of all, what is armature winding? Armature winding. Armature winding may be defined as an arrangement of conductor to produce EMF by relative motion in a heteropolar magnetic field. So, what is the armature winding? So, armature winding is depends on. So, armature winding may be defined as an arrangement of for conductor to produce EMF by relative motion in a heteropolar magnetic field. So now we will discuss the winding of an actual armature. But before doing this, the meaning of the following terms used in connection in armature winding should be clearly kept in mind. Uh, So pole pitch is a pole may be various defined as the periphery of the armature divided by the number of poles of the generator, that is the distance between two adjacent poles. It is equal to the number of armature conductors per pole. If there are 48 conductors and 4 poles, then pole pitch is 48 by 4 equal to 12. Next, conductor. Conductor, the length of your wire laying in the magnetic field and in which an EMF is induced is called as conductor. As for example, the length AB and or CD, uh, the coil or winding elements with reference of the figure, the two conductors AB and CD along with the end connection constitute one coil or winding element of the armature winding. The coil may be a single turn coil or multi-turn coil. A single turn coil or a winding element will have two conductors, but a multi-turn coil may have many conductors per coil set. Each coil set has three conductors. The group of wire or conductors constituting a coil set of a multi-turn coil is wrapped with a tab as a unit and is placed in this armature slot. It may be noted that since the being and the end of each winding element must be connected to the commutator bar, there are as many commutators bars as winding elements for both the lap and wave windings. Coil span or coil pitch by AS. It is the conductor distance measured in terms of armature slot, armature mm, between two sides of a coil. It is in phase the periphery of the armature spanned by the two sides of the coil. If the pole span or coil pitch is equal to the pole pitch, as in the case of coil A, where pole pitch of 4 has been assumed, then winding is called full pitched. It means that coil span is 180 degrees electrical degrees. In this case, the coil sets lies under opposite poles, hence induced EMF in them are additive. Therefore, maximum EMF is induced in the coil as a whole, it being the sum of the EMFs induced in the two coil sides. For example, if there are the 36 slots and 4 poles. Then for coil span is 36 by 4 equal to 9 slots. If number of slots is 35, then ys is equal to 35 by 4 equal to 8, because it is a customary to the drop fraction. If the coil span is less than the pole pitch, then the winding is fractional pitched. In this case, there is a phase differential between the EMF in the two sides of the coil. Hence, the total EMF around the coil, which is the vector sum of the EMF in the coil in the two coil sides, is less than this case as compared that in the first case. Pitch of a winding in general, it may be defined as the distance around and the armature between two successive conductors which are directly connected together, or it is the distance between the being of two consecutive turns, y equal to yb minus yf. So for lap winding, ys plus yb plus yf for wave winding. It is practice coil pitches as low as 18th of a pole pitch are employed without much serious reductions in the EMF. Fractional pitched winding are properly few pro- proposally used to effect the substantially saving in the copper of the end connection and the improving commutation. Back pitch YB. The distance measured in terms of the armature conductors, which a coil advance on the back of the armature is called back pitched and is denoted by the YA. YB. So element 1 is connected on the back of the armature to element 8. Hence YB equal to 8 minus 1 equal to 7. So front pitch coil YF, the number of armature conductors or elements spanned by the coil on the front commutator end of the armature is called the front pitch and designated by YF. Again, element 8 is connected to element 3 on the front of the armature. The connections being made at the commutator segment. Hence, YF equal to 8 minus 3 equal to 5. Alternatively, the front pitch may be defined as the distance between the second conductor of the coil of one coil and the first conductor of the next coil, which are connected together at the front, that is the commutator end of the armature. Both the front and back pitches are just for lap and wave windings. Resultant pitch YR. It is distance between the being of one coil and the being of the next coil to which it is connected. As a matter to precautions, it should be kept in mind that all these pitches, through normally stated in terms of the armature conductors, are also sometimes given in terms of armature slots or commutator bars, because commutators there is after all an images of the winding commutators. The commutator pitch by C. So first of all, the armature winding may be defined as the arrangement of conductors to produce EMF by relative motion in heteropolar magnetic field. So terms related to armature winding: conductor, overhang, turns, coil side, coil span or coil pitch, pole pitch, back pitch, front pitch, winding pitch, commutator pitch, number of schemes. So first and single layer and double layer winding, depending upon the physical arrangement of conductors or coil sides in a slot. The armature winding can be classified into single layer winding and double layer winding. So first and is a commutator pitch of the commutator pitch YC. It is the distance between the segment to the which is two ends of the coil are connected. For it is clear that the lamp winding YC YC is the difference of YB and YB and YF, where, whereas for the wave winding it is the sum of YB and YF. Obviously, commutator pitch is equal to the number of bars between coil leads. In general, YC equal to the plex of the lap wound armature. Hence, it is equal to 1, 2, 3, 4, etc. For simplex, duplex, triplex, and quadruplex, and is lap wind, etc. and lap winding. Single layer winding. So, single layer windings are it is that winding is which single layer winding. It is that the winding in which one conductor or one coil side is placed in each armature slot, such as a winding is not much used. Two layer winding. In this type of winding, they're arranged in two layers. Usually, one side of every coil lies in the upper half of one slot, and another side lies in the lower half of some other slots at distance of approximately one pitch way. The transformer of the coil from one slot to another is usually made in a radial plane by means of a peculiarly bend or twist at the back end. Such winding in which two coil sides occupy each slot are most commonly used for all medium-sized machines. Sometimes 4 or 6 or 8 coil sides are used in each slot in several layers because it is not particular participable to have to many slots. The coil sides laying at the upper half of the slots are numbered odd, that is 1, 3, 5, 7, etc. While those at the lower half are numbered even, that is 2, 4, 6, 8, etc. Degree of re-entries of an array armature winding. A winding is said to be slightly signally a re-entry of and tracing through it once all armature winding conductors are included on returning on to the starting point. It is doubly re-entered if only half of the conductors are induced in tracing through the winding once, and so on. Lap winding and double layer, single layer and double layer winding depending upon the physical element of conductor or mm, coil sides. In short, the arrangements winding can be classified as single layer winding and double layer winding. Single layer winding lift a wedge coil sides or conductor. Next one is single layer and double layer winding. There is a two coil side, top coil side and a bottom coil side. The bottom layer and a separated insulators, top layer and windage lips. So comparison between closed and open type winding. So closed winding and open type winding. In this winding, there is a closed path around the armature periphery. In this winding is not closed. Instead, the armature may be left open at one or more points, forming the several sections. These windings are always double layer type. These windings can be either single layer or double layer types. Closed windings are used in DC machines. Open windings are used in AC machines, induction or a synchronous machine. Design is not flexible. Flexible design in open winding, and closed windings to design to not flexible. Open winding is a flexible design. In these windings, there is a closed path around the armature. In this winding is not closed. Instead, the armature may be left open and at one or more points, forming the several sections. These windings are always double layer type. These windings can be either single layer or double layer type. Closed windings are used in DC machines. Open windings are used in AC machines, induction and synchronous machines. Design is not flexible. Flexible design. So next one is types of DC armature winding. So first one is uh, branch polarities, lamp winding, dumb winding, lap and wave winding. It is used in this case of four types of generators separately. So according to progressive and regenerative lap and wave winding, according to the way of connecting the conductors and DTC armature windings are classified into lap winding and wave winding. Lap winding, the way of connecting armature coil sides to the commutator. There are two types of lap windings: progressive lap winding and retrogressive lap winding. So first one is a lap winding and advantages of wave winding. Winding is that for a given number of poles or armature conductors, it gives more EMF than the lap winding. Conversely, for the same EMF, lap winding would require large number of conductors, which will result in higher winding cost and a less efficient utilization of a space in the armature slot. Hence, wave winding is suitable for small generators, special for those meant for 5 to 600 volt circuit. Another advantages is that in wave winding, equalizing the connections are not necessary, whereas in a lap winding, they definitely are. It is so because each of the two path contains conductors laying under all the poles, whereas in lap one armature, each of the P-parallel path contain conductor which lies under one pair of poles. Any inequality of poles flexible flexes affected two paths equally. Hence, their induced EMF are equal. In wound armature, unequal voltages are produced which set up a circulating current and that produces sparking at brushes. However, when large currents are required, it is necessary to use lap winding because it gives more parallel paths. Hence, lap winding is suitable for comparatively low voltage but high current generators, whereas wave winding is used for high voltage, low current machines. So front pitch coil and resultant pitch coils are so front pitch coil. The number of armature conductors or elements spanned by the coil on the front armature is called the front pitch and designated by the IF. Again, elements 8 is element connected to elements 3 on the front of the armature. The connections being made the commutator segment, and so YF equal to 8 minus 3 is equal to 5. Alternatively, the front pitch may be defined as the distance between the second conductor of the one coil and the first conductor of the next coil, which are connected to element 3 on the front of the armature. The connections being made at the commutator segment, hence YF equal to 3 by 8 minus 3 equal to 5. Alternatively, the front pitch may be defined as the distance between the second conductor of the coil and the first conductor of the next coil, which are connected together at the front, that is commutator end of the armature. Both front and back pitches for lap and wave windings are shown. The resultant pitch wire, it is distance between the being of one coil and being of the next coil to which it is connected. Uh, as a matter of precautions, it should be kept in mind that all these pitches through the normally started in terms of the armature conductors are also sometimes given in terms of armature slots and armature bars because commutators is after all an images of the winding. Commutator pitch YC is the connection in the distance between the segment to which two ends of a coil are connected. It is clear that for lap winding, YC is the differences of YB and YF, whereas for wave winding, it is sum of YB and YF. Obviously, commutator pitch is equal to the number of bars between coil leads. In general, YC equal to the flex of the lab on armature. Hence, it is equal to 1, 2, 3, 4, etc. for simplex, duplex, triplex, and quadruple etc. lab winding. Single layer winding is it is that a winding which one conductor or one coil side is placed in the each armature slot. Such winding is not much used. Two-layer winding. In this type of winding, there are two conductors or coil sides per slot arranged in two layers. Usually, one side of every coil lies in the upper half of one slot, and another side lies in the lower of some other slots. A distance of approximately one pitch way, the transfer of the coil from the one slot to another is usually made in a radial plane by means of the particularly bend or twist at the back end. Such winding in which two coil side occupy each slot are most commonly used for all medium-sized machines. Sometimes 4 or 6 or 8 coil sides are used in each slot in several layers because it is not but participable to have too many slots. The coil set laying at the upper half of the slot are numbered add odd 1, 3, 5, 7, etc. While those at the lower half of the R are a number even that is 4, 2, 4, 6, 8, etc. degree of re-entrancy of an armature winding. Winding said to be slightly entered if on and racing through it once all armature conductors are included. On returning to the starting point, it is doubly re-entered if only half of the conductors are included in racing through the winding once and so on. Lap winding and wave winding. The two types of windings mostly employed for drum type armatures are known as lap winding and wave winding. The difference between the two is merely due to the different arrangement of the end connection at the different front or commutator end or armature. Each winding can be arranged progressively and retrogressively and connected in the simplex and duplex and triplex. The following rules, however, apply to the both type of windings. The front pitch and the back pitch are each approximately equal to the pole pitch. That is, winding should be full pitch. This resulted in increased EMF around the coil. For special purpose, fractional pitch windings are uh, deliberately used. Both pitch both pitches should be added, or the otherwise it would be difficult to place the coils properly on the armature. For example, if YB and YF were mm, both even, then all the sides and conductor would be like either in the upper half of the slot or in the lower half of. Hence, it would become impossible for one side of the coil to lie in the upper half of one slot and the other side of the same coil to lies in the lower half of some other slot. The number of commutator segment is equal to the number of slots or coils because the front ends of conductors are joined to the segment in pairs. The winding must close upon itself. That is, if we start for a given point and move from one coil to another, then all conductors should be traversed and we should reach the same point again without a break or discontinuity in between. Simplex lap winding, it's shown, which employs single turn coil. In lap winding, the finishing end of one coil is connected to the commutator segment and to the starting end of the coil, adjacent coil situated under the some same pole and so on until all the coils have been connected. This type of winding derives it may name from the fact it double or lap back with the succeeding coil. Lap winding, the back pitch, the condition for a simplex form, simplex lap winding. It is shown that which employs a single layer turn coil. The lap winding, the finishing end of one coil is connected to commutator segment, and the starting end of the adjacent coil situated under the same pole, and so on till all the coils have been connected. This type of winding derives its name from the fact it will double or lap back with the succeeding coil. So condition for the simplex lap winding, back pitch YB and front pitch YF must be nearly equal to the pole pitch. YB and YF must be odd numbers. They should not be equal, but different between them should be equal to 2. Commutator pitch YC should be plus or minus 1. Winding pitch Y should be even number. Uh, from the above conditions, we conclude that YB equal to 2C by P plus or minus K and by B equal to by R plus or minus 2. C is the number of coil, P is the number of poles, K is the number of making back pitch by B and odd integer 2C by 2C by P must be even to make the winding possible. So the following points regarding to simplex form lab winding should be carefully noted. The back pitch and front pitches are odd and of opposite side, but they cannot be equal. They differ by two or some multiple further. Both YB and YF should be nearly equal to the pole pitch. The average pitch YA equal to YA plus YB plus YF by 2. So commutator pitch equal to YC equal plus or minus 1. The resultant pitch YR is even, being the arithmetical difference of the two odd number. The number of slots for two-layer winding is equal to the number of coil. The number of commutator segment is equal, also the same. Number of parallel path in the armature is equal to M into P, where the M is the multiplicity of the winding and P the number of poles. Taking the first condition, we have Pi by B equal to YF plus 2. However, the where heavy currents are necessary, duplex or triplex slab winding are used. The duplex slab winding is obtained by placing two similar windings on the same armature and connecting the even numbered commutator bars to have to one winding and the odd number ones to the second winding, similar to the triplex lap winding. There would be there three windings such connected to one third of the commutator bars. Progressive lap winding as the retrogressive lap winding, AC armature winding. So AC armature winding, AC machines start the AC machines they start our AC armature winding in which the alternating EMF is included. The winding armature, if a DC machines is closed, and the closed winding are always double layer type. The winding used for armature and AC is open. The open windings are can be either single layer or double layer type. The terms related to the to AC armature winding, coil span, full pitch winding, short pitch winding, shorted winding, integral slot winding, fractional slot winding. So full pitch winding and short pitch winding is a layer, is a coil span. So conductor is defined as the length of the laying in the magnetic field. The coil, two conductors with their end connection from the one coil. The coil may be single turn or multiple turn. Coil pitch and coil or coil span. The distance between the two coil sides of a coil is called coil pitched. Pole pitched and pole span. The angular distance between the center of the two adjacent poles on a machine armature is known as pole pitch. One pole pitch is equal 180 degrees electrical equal to 180 degrees electrical equal to slot per pole. Single layer and layer, full pitched and short pitched coil. Switched coils depend when the two coil sides of a coil sides of a coils are 180 degrees electrical for the coil is termed as full pitched coil. In other words, if the coil pitch is one pole pitch, it is called full pitch coil. However, if the coil pitch is less than one pole pitch, the coil is called short pitched or fractional pitch coil. In full pitched coil, the EMF of the coil sides are in phase they may be added automatically. In a short pitched coil, the EMF of the coil sides are not in phase, and so in the resultant EMF in a coil is the vector sum of the induced EMF is less than less than their arithmetic sum. Therefore, due to short pitch, the induced EMF decreases by factor called as pitch factor. Advantages and disadvantages of short pitch coil and the distance such as we have waveform of the induced EMF is improved, and the distorting harmonics can be reduced, saving of copper in end connection. Mechanical strength of the coil is increased. The Indian inductance of the winding is reduced. The fractional number of slots per pole can be used, which in turn may reduce in the tooth ripple disadvantages. EMF for coil decreases to some extent. Pitch factor and shorted friction and shorted pitch factor is pitch factor or coil span factor or shorted pitch in the pitch factor is defined as the ratio for resultant EMF ER when the coil is a shorted pitch to the resultant EMF when the coil is full pitched. Pitch factor equal to Kp equal to EMF with the short pitched winding by EMF with the full pitched winding. So equal to vector sum of the induced EMF per coil arithmetic by arithmetic sum of induced EMF per coil. It is always less than the unity Kp equal to less than 1. And fractional start pitch. Winding factor is sum of the coils and EMF variances. If the coil full pitched is then the total induced EMF in coil 2AS. If the coil is short by the an angle alpha, then the resultant EMF E will be uh, the vector sum of two voltages E equal to 2 ES cos alpha by 2. Pitch factor Kp equal vector sum of the induced EMF per coil, arithmetic sum of EMF per coil, E by 2 ES, 2 ES cos alpha by 2, 2 ES by divided by 2 ES, Kp is equal to cos alpha by 2. Distribution factor or spread factor Kd. Distributed factor is Kd. The distance of a distribution factor Kd is defined as the ratio of resultant EMF ER when the coil are distributed to the resultant EMF E when the coil are concentrated. Kd equal to EMF induced in distributed winding by EMF induced in concentrated winding equal to vector sum of the induced EMF uh, by arithmetic sum of induced EMF coil voltage per phase. Kd it is always less than unity Kd less than Kd 1. Commonly used AC winding. The following types of windings are most commonly used for the stator of AC machines. That is single layer mesh winding. And this winding is used for small induction motors. Double layer lap winding. So double layer lap winding. This winding is commonly used for the medium and large size of size size AC machines like induction motors and synchronous machines. Designs and development of mesh winding, this single layer winding and single layer winding must windings. This single layer winding and is most commonly used for small induction motors. Small induction motors. Conditioner for designing a winding. The coil must should have constant span. Should be it should be constant span. There should be one coil side per slot. It means that the number of coil sides equal to number of slots. There should be only one coil group per phase per pole phase. The coil span must be odd integer. The effect of the chartered factor, the full pitched coil chartered factor, the pitch factor Kp is equal 1 and for short pitched coil Kp less than 1, less than 1, which factor can be used to reduce or eliminated specific harmonic frequency in the generated voltage waveform. An alternative small, mostly short pitched coil are used, hence the resultant EMF induced in coil is reduced and is given by multiplying the pitch factor with the resultant EMF in the coil when it is full pitch. Distribution and the breadth or spread factor. Distribution factor KD is defined as the ratio of resultant EMF here when the coil are distributed to the resultant EMF when coils are concentrated. So the coil must be, they should have constant span. There should be one coil say per a slot. It means that the number of coils inside equal to number of coils or slots. There should be only one coil group per phase, pole per phase. This coil span must be odd integer. Thank you.